Hi. Today we're going to look at angles, and specifically we're going to probably review some things you already know with naming angles. We'll do a little measuring, but it's kind of hard to do measuring now with, you may not have access to a protractor, so we'll kind of deal with that when we get back in school, and we're going to review classifications. Okay, let's sketch some pictures here on these first ones. So an angle is our first term. So an angle is formed by two rays with a common endpoint. Now we could draw opposite rays, which remember would make a line, but we're going to draw non-opposite rays for this picture. So here is one ray, here is another ray, so therefore I've drawn an angle. Now, two opposite rays also make an angle. We typically think of this type of thing when we draw an angle. Next, we have congruent angles. So, congruent, remember, means the same, or equal is probably a better word, but they are angles that have the same measure. Okay, so for example, if I have one angle here, and I have a second angle over here that have the same measure, they'd be considered congruent. And so to show that symbolically, you'll often see a small little arc in the vertex. And when I have the same number of arcs, these both have one arc, therefore they're congruent. I could have a second set of angles, like maybe I have one right here, and I have one right here. Most of the time you'll see this all in one picture, but sometimes you'll see double arcs like that. Okay, so if you've got one big picture where you've got, let's say you've got like 6 angles and you're trying to show a set of 2 is equal to each other and then a different set of 2 are equal to each other, you'll often see single arcs and double arcs. Okay, classification: acute, obtuse, right, and straight. So typically we think of acute angles as angles that are less than 90 degrees. But less than 90 degrees, they can't be negative degrees. So here's how I'm going to write this. I'm going to say that M is my measure. I'm going to say it's less than 90 degrees, but it's greater than 0 degrees. Okay, so it's really a range in between 0 and 90. Let's do the same thing on obtuse. We typically would say it's greater than 90, but it also has to be less than 180. So I'm going to say my measure here. I'm going to say greater than 90. At the same time, less than 180. Okay, and so these are called compound inequalities. You use them or you solve them a little bit in Algebra 1, but this is another place that they have value to show us a range of numbers. Right angles are equal to 90, so M is equal to 90 exactly. And then straight angles. So that's the one I said where you could have an angle that are opposite rays like this. So the measure is exactly 180 degrees. Okay, so you'll have some questions that say, find the measure of angle A and then classify the angle. And so these words, acute, obtuse, right, and straight, they're considered classifications. So that's what you want to enter or answer as the response. Okay, let's move on to angle addition postulate. This is a phrase that you will need to know. Angle addition postulate. So it's identical to our segment addition postulate, but it applies to angles. If point D is in the interior of angle ABC, okay, so let's draw that first of all. So draw yourself a pretty large angle, and it needs to be called ABC. So since B is in the middle, that's your vertex. And it doesn't matter where A and C land, but it needs to go on either of the rays. So if you have point D, let's just say D is on the interior, let's go ahead and make a ray from B through D. So we're going to have point D create 2 interior angles. So if you have a point in the interior of an angle, then this following statement is true. The measure of ABD, so ABD is this angle right here. Okay, so this angle right here plus the measure of DBC. DBC is this angle here. So this angle plus this angle equals the measure of ABC. Okay, it'd be like saying, if this angle is 30 degrees and this angle is 50 degrees, well, when I add them together, I get 80 degrees as my angle, okay? And then you could say, well, you know, let's say I didn't know 50. If this is 80 and this is 30, then I get 50 as my answer. All right, so we'll use that idea to set up some equations later on. Okay, angle bisector. So there's that word bisector again, where it cuts things in half. An angle bisector is a ray that divides an angle into two congruent angles. All right, so let's draw another angle picture. And then I'm going to draw a ray here, and it's going to break that angle in half. So in order to show that's the bisector, I'm going to put two arcs like that. That tells me, I don't know, maybe don't know exactly the measure of them, but that tells me that those two angles are congruent. Okay? All right, let's move on to some examples. Example 1 here. Name all the angles in the diagram. So we want to use our proper notation. As you saw above, this is our angle symbol right here. So I actually see 3 angles in this picture. I see the 2 interior, and then I see the larger angle. So when I name an angle, it's crucial that the vertex is in the middle. So I'm going to name this top angle here. It's called WXY. So angle WXY. Now I could switch these first and last letters around, okay? So I could have named that angle YXW and gone this direction with it, all right? Second angle, YXZ, so angle YXZ, or again, you could switch the Z and the Y around, so you could have written this. You could have written angle ZXY. And then the large angle, angle WXZ, angle WXZ. Again, I could have switched them around. Now, in this particular diagram, I could not just say angle X. Sometimes you'll see angles named with the vertex. The reason I can't do that is because X is the vertex of 3 different angles. So which angle are you describing? If you had a picture that looked like this, let's say it was WXY, then that would be appropriate to call that one angle X because it's clearly just one angle with that vertex. So this one is a no for that picture. All right, let's move on to the next page. And I just want to briefly show you this because, like I said, I don't know if you have your own protractor. Normally in class, I would have some and we would just review how to use a protractor. So it looks like I don't even have my directions on here, but I wanted you to practice measuring. So I'll just show you real quick on one of them, and then if we come back together as a class and use it, or I might be able to get you a protractor tool on Schoology. So protractors are all a little bit different. This particular protractor, the hole right here is sort of like the 0 point, or where you line up the vertex. So on this particular one, I'm going to put the hole over the vertex here. And then this is like the 0 line here. I want to line one side of my angle up on that. Okay, so I would just kind of carefully, see how I don't have it lined up there? I would carefully line it up. And then see how it doesn't connect up there? What I like to do on this kind of a protractor is just extend it out. Now I do it one more time. Okay, so I get it lined up. That's about right. And then see how it's connecting here? So it's connecting either between 55 or between 120 and 130, 125. So you need to look at your angle and say, well, this is clearly a less than a 90-degree angle, so I'm going to go with this number here, and this is a 55-degree angle. Okay, but like I said, we're not going to do much measuring right now, so we'll come back to that if we need to. But that's how you would use a protractor. All right, let's look at this next example here. Given that ray KM is the angle bisector of angle LKN, Find the measure of LKM. Diagram may not be drawn to scale. So that just means if it is an angle that looks like it's less than 90, I may actually calculate a number bigger than 90. So here's what I want us to first do. When I read this angle bisector, so LKN, that means these two interior angles are equal. So I'm going to do this. I'm going to draw an arc here. I'm going to draw a small one because I don't want to cover up my numbers. So that tells me they're equivalent to each other. So if this 2x plus 10 is on this angle, 4x minus 3 is here. If the angles are equal, then those expressions are equal. So I can write this equation, 4x minus 3. And then from here, I just solve. Okay, so I would be able to minus 2 from both sides. So that would leave me with 2x on the right. Then I would have to plus 3, that would give me 13. And then divide by 2, that's 6.5, right? 13 divided by 2, 6.5. Okay, but I need to find the measure of an angle. So find LKM. LKM, okay, LKM goes with 2x plus 10. So I want to substitute 6.5 in for that expression. So 2 times 6.5, so I'm back to 13. 13 plus 10 is 23. So I'm going to say that the measure of LKM equals 23 degrees. Okay. So interpreting that term angle bisector, that's going to be what you need to do to get this particular example set up. All right, what I would like to do, I'm gonna stop this video here. The next couple examples are a little bit lengthy on the algebra side, so go ahead and move on to the next video. If you want to try the rest of them on your own and then watch the video, that'd be fine too.